Okay, we are doing today Module 3, Lesson 6. The biggest change from the previous lesson is that this lesson has mixed numbers that we need to convert into an improper fraction because there's only one of them in this case. And I think in every question, especially on the first page, I know every question has just one of these. So let's look at what we need to do. We need to take this number and make it into just one fraction. Then we can subtract the other fraction from it. We can't have a mixed number and then subtract a fraction. It's just not possible. So we got to change it, and what we do is we take this 1 and we turn it into a fraction. 1 can be any number of fractions. It can be 1 over 1. It can be 3 over 3. That's a 3. It doesn't look like a 3 though, does it? Yeah, well, it could be 10 over 10. Anything divided by itself is 1. So, does it make sense to use a particular number? Definitely. If we make 1 into a number that has a 3 on the bottom, only one possibility exists for the top 3. We'd use 3 because we're dealing in thirds. 2/3 is added to this 1. Before we subtract anything, we can worry about that later, but we're in thirds, so turn 1 into thirds also, and then you can just add them. So 3/3 is 1, plus 2/3, and that equals 5/3. Yes, it is an improper fraction, but we can worry about that later, and we're subtracting, so it's not going to affect it in the long run. So now that we know that's 5/3, I'm going to erase everything. We can cross out that 1, and we can cross out 2/3. So really all of that is 5/3. Then it's just a normal addition or subtraction of fractions, and we just do the same process we've been doing for the previous 2 to 3 lessons. So that's really the only change from other lessons. So minus 3/5. I'll still work it out though here just to refresh our memories. Least common denominator, also called least common multiple. We need to get that before we can subtract fractions because they have different denominators, so we need to have a common denominator. So just count by 3s and count by 5s until you get one that is on both sides, that is common between them. 3, 6, 9, 12, 15. Okay, let's go here. 5, 10. Remember, you can use the number that's already there too. Any number in this line. 5, 10, 15, 20, and you may have noticed the winner already. I call them the winners. 15 is on both sides, so that's our new denominator. So that's got to be our new bottom. 5/3 becomes 15ths now. We don't know how many 15ths. There's a couple ways to do this, and I've heard students come in and say they worked on it with parents and there's a different method. There are different methods. This is the way that works. It's one way that works, and I like it because it's very simple and it follows what we've been doing in class. So the students are familiar with it. There are other ways though. 3 to 15 is times 5, so that means I have to times 5 and multiply the top by 5 to get, 25. So 5/3 is dead now. Now we only have 25 over 15. Now let's do the same for 3/5. We got to turn him into something with 15ths on the bottom. And in this case, let's see. Since they're equivalent, that's why we can do this, by the way. The equivalent fractions enable this. 5 to get to 15 is times 3. So 3 times 3 is 9. 9/15 is the second fraction. So cross him out, cross him out. So really, it's 25/15 minus 9/15. 25/15 minus 9/15. And since the bottoms are the same, you don't have to do anything to the denominator. You just are subtracting the numerator. So 25 minus 9 is 16 over 15. And that's how you solve it. Whoops. There we go. All right. Have a nice night.